This is my 555 time machine breadboard prototype. This project uses a 555 timer IC, which is a chip that can create an astable and monostable square wave. To create an astable square wave, you add a pair of resistors in series along with a capacitor. This is a deconstructed version of the 555 timer IC as an astable circuit. Within the 555 timer IC are 3 equal resistors in series, typically 5k ohms, a transistor, 2 comparators, an SR latch, which can be made through NOR gates, and an inverter, which can also be made through NOR gates. Here's a breadboard prototype of an SR latch. As you can see, when an input is set, the output will stay on even after the input is low. It will only ever turn off if the reset pin is turned on. The current starts by flowing through the 1 and 100k resistors until it reaches the capacitor. As the capacitor begins to charge, its voltage increases. Once the voltage reaches 1.67 volts, the trigger comparator will turn high since the inverting input voltage is greater than the non-inverting in that comparator. Since the output is connected to an SR latch, the state of the latch output will not change, and the latch output will remain low, so the LED will be high since it goes through an inverter. As soon as the voltage from the capacitor reaches past 3.33 volts, the non-inverting input will have a greater voltage than the inverting input in the threshold comparator, so its output will turn on and the latch will reset. This causes the SR latch output to turn high, so the LED output will be low, and the current from the output will flow to the base of the transistor, which allows it, along with the charge from the capacitor, to flow to ground. As soon as the capacitor drains its voltage to below 1.67 volts, the trigger will turn high, since the inverting input has a lower voltage than the non-inverting. This will set the latch again, and the transistor will stop flowing to ground. The LED will turn back on, and the capacitor will begin to charge again. This cycle repeats itself indefinitely. Adjusting the size of the capacitor, or the resistance of the 2 resistors in series, will adjust the frequency of the square wave. Where the higher the resistance, or the bigger the capacitance, the slower the frequency will be. This can be shown through a potentiometer.